Okay, hi. I'm gonna give a demo for my Chainlink Hackathon submission. Um, so I'll quickly explain the goal of this submission. The basic idea is that we wanna validate if a marketing campaign done by an external agency has delivered the ROI that the agency promised, and only if that ROI, return on investment, let's say, has been reached, we will release the funds that were agreed upon to be paid for this campaign. We can also do partial payouts, or the company that has requested the campaign to be performed can ask for a refund when the campaign is unsuccessful. So to start off with all of this, of course, we need to know whether or not a campaign is successful. And the way we do this is by gathering Google Analytics data. Google Analytics has a feature that it can dump this clickstream data. So every user that clicks on a website on any button, that is streamed into Google BigQuery, which is Google's managed service for a data warehouse where we can actually query terabytes or petabytes of data in a matter of seconds. So I'll quickly just show you what that table looks like. So we have here a data set, which is actually just a view on the official data set, which I cannot share because of a lot of PII data, but this is just a view that queries specific data that is required for this job. So if we can quickly see, this is actually just select view from our actual data set, and I'm just extracting these values rather than IP address and all those things, which we want to avoid showing here. Um, so if I just query to see what's in here, we can see that we are um, querying, let's say, to 23,000 records in just a matter of seconds. So what is in here? Of course, the full visitor ID, which is a unique ID per user, per session, that we actually want to track. So if a user is visiting our website, we get a new visitor ID for a new customer or a new user, and we can actually see by the likes of a UTM parameter if that was actually successfully linked here through a marketing campaign or if it was an organic reach. So I think that that value should be in here somewhere. So traffic source, that actually shows where the user came from. So we will add, for a new marketing campaign, we will add a new source. So if we just filter on this source campaign in our query, then we can see how many new visitors actually visit this website purely through clicking on advertisement or an email campaign. This is the actual query that we will be running to see how many visitors were visiting from a specific campaign. Let me quickly format this a second here. Traffic source, and then here is actually our campaign ID that we need to fill. So if we have a campaign ID called Chainlink campaign, then we can actually query and see how many unique visitors we actually had coming to our website because of this campaign. If we just say random campaign, and we run this, of course we will get 0 because there has been no hits on our website with this campaign. Going back to the Chainlink campaign, we see that we have 25 visitors. There must be a typo. There is. Like this. We have 25 visitors, and if we visit the website now, with here in the source, the UTM source, I use this campaign, Chainlink campaign. So I'm visiting the website now. This is actually being streamed into my data set. I am gonna disable cache for a sec. Use cache results, disable this. Run it again and we should see, no, sorry, I need to do this in incognito mode, of course, because I'm not a unique visitor, because I visited the website already, so I have a cookie. Now I'm visiting it in incognito mode, and if I query now, it should say 26. There you go, 26. We can just make a new campaign at any second, Chainlink campaign 234. At this point, of course, there is no hits for that. But now if I visit it, here in my browser, because this is a new one. I don't have a cookie for this one, for this campaign. So now I see there's one visitor for this campaign. So that's the main goal. We link this URL parameter to every campaign item we send out, being in an email or a Google ad. And if that generates traffic, we can actually see that traffic coming back into BigQuery here. Okay, so this is our basically our data source. What we then have deployed is a cloud function that is functioning as an external adapter to our Chainlink node, which we can see here. Let me quickly go into it. So if we look at the source for the bridge here, we can see that we are executing this query, and then we are returning this, the result of this query here to our node that will return this to our smart contract. There's some logging here for debugging, which shall be removed still. So we add the amount of visitors to the unique visitors value here, and we're actually parsing the data that we get from the smart contract. We're not having a fixed campaign. We actually extract this campaign ID here from the data that's being sent to the job. So in our job spec, we will have a campaign ID, which will relate to this campaign ID that we actually want to query for. So nothing is hard coded here, except from the data set, of course, as there is only one data set available at this point. Somebody else wants to deploy this, we should dynamically add these data sets as well. But for the scope of the hackathon, that was not done, as this should show actually sufficiently what the goal is here. So closing this, we can then test this this adapter. So we have a campaign ID Chainlink campaign. We have the endpoint of this cloud function, this one here, and then we send the request, and we should see 26 visitors now, because this test was done before with 25. Here we got 26. So going for the what was it, 3 to 4? That should give me one visitor. Did I make a mistake here? Oh, an underscore. So that was a mistake. That should give me one visitor. Yep, there we have it. So now we can use this adapter in our job spec as a task to be performed within the job, and extract actually this value in our smart contract. So we have a job spec, which is here, which is using the BigQuery adapter, and then using the copy, because we already return a full JSON response. It's not stringified. We can just use a copy. We convert it to an int, a uint, and then push it back on the chain like this. So in our own Chainlink node, which is deployed on a VM in Google Cloud, we actually have our Oracle contract address being deployed. So our node is registered as an Oracle with this address, which is actually used in the smart contract, together with this job. So this job is just an instantiation of the job spec that I just showed you already, and this is the Oracle address. Then we have the bridge, of course. So we have a BigQuery adapter, which is pointing to the endpoint we already tested out here. So now our node is set up, our node is linked as an Oracle. It can also connect to BigQuery thanks to this cloud function. So now it's time to deploy the smart contract. I'm actually gonna pause here and record the second part separately. Okay, so now for the second part, actually using our custom adapter in our smart contract, I'm going to deploy this contract. Small note, I just noticed that it didn't work before, and that was because I made a small typo. Here I actually was returning viters instead of unique visitors. So now it says unique visitors, so that's a small change I still made from when I stopped recording 10 minutes ago. But now this is actually not a typo, and it should return decently. You can see this. It said unique visitors. If I run it again, it should say unique visitors. Great. So all good to go now. Let's go here in some detail. So this is our own Chainlink Oracle. This is the Oracle address that we have here. And then we have the job spec, the job ID, apologies, here, which is being used here. Of course, these should be variable as more nodes deploy my adapter, but at this point, I'm the only one using my adapter, so that's why I'm just using it statically, and I cannot do any aggregation, of course, with this single Oracle. I could host more, but I wanted to focus more on the end-to-end rather than just focusing on aggregation, but that's for sure the next step to do. So what we will do here, there's a lot of validation, of course, going on. We have a function to register our campaign that will validate our input and then register the marketing campaign with the amount of ether that is paid out if the specified amount of visitors required has been reached. All code is being documented here for further reference. Small notice, we have visitor increment. So let's say we want 1,000 visitors or 100,000 visitors to be paid out, but the marketing agency wants some intermediate payments, then we can choose to increment in size of 25,000. So we will have 4 increments. If we pay out 1 ether, for example, we will have 0.25 ether being paid out as these targets of 25, 50K, 75K, and 100K visitors are reached. And of course, once we are on top of that, over that, nothing is going to be paid out anymore. There's a lot of checks in here, but I leave that to the jury to go over those. I'm not going to make this a half-hour video. And then there's request campaign payout. So this can be run by the agency when it knows or when it wants to check, am I eligible for some payouts? This will actually use my job ID and send that request to my Oracle to call my custom adapter to actually retrieve the amount of visitors that this campaign has generated. So from before, we know we have 26 already. So I'm just going to do a simple demo to say like we need 25 only, so it can be paid out immediately. Later on, we can do some partial payouts in this demo. And this is of course the fulfillment to check. This is the logic checking if we should do partial or full payouts. And one last thing, there's a cancel campaign. So if a specific expiration date, so an epoch, seconds timestamp has been crossed, then actually the customer can request a payback because it feels the campaign was unsuccessful, or a partial payback if, of course, already some sub-targets have been hit. This is also very transparent for the marketing agency, so they know their deadline, they know their partial payouts. Everything is managed by this smart contract. So no time for discussion on targets. After the contract has been created, the agency can validate the inputs for the contract and decide whether or not it wants to proceed with creating the campaign and putting all the effort in, because it knows when it does it, it will be eventually be paid out if successful. So I have 2 addresses here in my MetaMask. So one is the customer, and the agency is quite broke, but my customer luckily has 26 ether to 29 ETH to spend. So let's quickly deploy this contract with my customer account. It doesn't matter actually who deploys it. It's the one who registers the campaign who owns the funds initially. So deploying our Robston. Giving it some time. Could have done this actually before when I was talking through the code. Shouldn't take that long though, as you might know. Okay, there we go. And now we have a register campaign here. Of course, we still need to send my contract some ether, some link. So let's quickly provide it some link. Okay, I got myself quite some test link, as you can see, making it as fast as possible. Sending some 10 links to my contract. And once this is done, I can already register actually. It's only when the oracle is being called that my link is needed. So let's say we have a campaign called Chainlink campaign like this. Let's say we need 25 visitors for this campaign to be successful. We will increment in size of 25, which means a full payout, either everything or nothing. If I put this at 10, then partial payouts can be done on the first 10, then at 20, and then 25, which is all logic in the code. But just let's keep it at 25 for a full payout. Of course, I need to provide 1 ether here. So there was actually something to be paid out. Okay, my transaction confirmed. Now I need the address of my agency that needs to pay out. So I copied that. I switched back to my customer actually in my MetaMask because the customer needs to register that campaign and pay that 1 ETH out of its 29. If I wouldn't have done that, my agency would be paying itself. So an expiry, we can say epoch converter, let's say, let's give it 1 day. And this is our epoch timestamp in seconds, which is going to be the threshold for when the target must be reached. All looks good, so let's deploy. Let's create a transaction, I meant, of course. Now it would be great to have Dan because he can talk through all of this waiting, but I'll do my best. Okay, there we go. And if I now look at the testnet, so I copied my address here. Let's look at my contract quickly. So it has 10 link and it also has that 1 ETH from registering my campaign here. So my company only has 28 and the contract now has 1 ETH. We can also see the event here that the registration was done. So time passes by and I am now the customer, sorry, the agency. Let's quickly switch to that role. Okay. And I'm like, I want to get paid because I know I reached my target. I can actually check. So if I fill in Chainlink campaign here, I can see nothing has been registered yet because the oracle hasn't been called. But I can already see what my target is. This is the target that we registered first. So I know that I need to get to 25. Currently I'm at 0. Actually, we're at 26 already, but we need to fetch that data from our oracle. So let's go here. Request campaign payout. Whoops. Paste the campaign ID. Run that transaction. Confirm that transaction. And what is being done now? We should be watching our Chainlink node. So let's refresh here. Nothing coming in yet. But as my transaction confirms, I should be seeing a job triggered here. So, okay, my transaction has confirmed. Refresh this. And okay, awesome. My job is being triggered. It's executing. It's fetching data from BigQuery. You could even see this in our logs here of our cloud function, which actually should show up here. Great. So I'm getting a request here. If this is our current time, yes, it is. Voila, unique visitors 26 and it returned at 200. So my cloud function succeeded, which means this one, we need to wait for the transactions, of course, to confirm before my node actually pushes this back to the blockchain. We can already see the interaction going on here on my smart contract. Actually, voila, we can see it has processed. So Chainlink requested, then it was fulfilled with the 26. Let's quickly see if we can find that here. Some of these numbers. This is the payment. So we needed 25 to do the payout. We did the full payout, and we actually had 26. So that's why the full payout happened. The payment was made. So looking into our agency now, voila, we have 1.8 Ether. The agency is super happy because it got paid. That's the basics, of course. One more thing we could do, and I cannot reuse the same campaign ID here, so because that would override an existing campaign, and then the agency could actually override the amount of visitors required if I could just override the campaign ID, so that ain't good. let's see, and let's say that we need 60 visitors in increments of 30. So we're at 26, we can easily get to 30. And again, let's add 1 ETH to that, switch into my customer again. And the expiry, I'm actually gonna put it on now, so that I can demo the fact that the agency, sorry, the customer can actually ask for a refund. My agency address is still fine, so this is my timestamp for now. I'm sending 1 ETH to this Chainlink campaign 1. I know, sorry, this campaign has not been triggered, so I'm just gonna put it at 10 increments of 2, because I don't have any data for this ID in my database yet, so that would return 0. Clicking to 30 would be a lot, so I'm just gonna increment by 2. Processing this transaction, yep, and I can already trigger some hits on this campaign ID. So that is 1. Check this, that we see this. Yep, that's 1. This is the second one, triggered. And of course, if it's below this number, the payout doesn't happen. Voilà. So I have 2 now, and my node has, sorry, my contract has been updated to register this campaign. Quickly inspect it, so ask what my target is. My next target is 2, and currently we know about 0. By the way, the previous one we knew about 26, that's why the payout was happening. So we actually have proof here that the oracle returns 26 in my previous example. But now we have 0 yet. We need to get to 2. Actually, we are at 2 yet at our database, so we know that the agency can request a payout. Let's do the same stuff again, like we did before. Request payout campaign. And if I would do this for this one, nothing would happen. Of course, it would not pay out the 1 ETH I just added to the second campaign. That would be a very nasty bug. But I expect the jury to validate all of that, of course. So I'm requesting a payout for Chainlink campaign 1, and actually it doesn't matter who requests the payout, it's always going to the agency. Now, as customer, I requested the payout, but it's actually still gonna end up with my agency, which now has 1.88 ETH, so there should be 0.25 added quite soon. Let's go back to my node. Yep, there's my job ID. Let's go into the logs here. Refresh, nothing yet. Refresh like that then. Oh, no, a transaction just confirmed only now. So, oops. So of course, only now we will be seeing my data here. Are my logs not showing up? Let's quickly see what's happening on my contract itself. Okay, request triggered. Oh, job executed. I'm not sure why the logs are not showing up. Okay, payment made. Voila, we're back. And now we can see that only a partial payout has happened. We can see this in MetaMask. We had 1.88, and now we're at 2. Yeah, it should add 0.2, not 0.25. That would be increments of 2.5 visitors, not 2. So 10 total required divided by 2 is slices of 5. 1/5 of 1 ETH is 0.2 ETH, of course. So we can actually see now that my contract only should have 0.8 ETH. Great, it paid 0.2 to my agency. And now let's say the customer is sick and tired of this agency. Nothing is going on. No new hits are coming, and the deadline actually has expired, which I took here to be now. So actually, our company has the right to request its ETH back, the remaining ETH, the 0.8, of course, which will be done. And actually, you can see the amount of visitors registered too. So I'm not sure why these logs actually messed up. Ah, there. Okay, finally. Phew. Was afraid something went wrong, but the logs are quite slow. But actually, we see 2 registered visitors. So let's say now we're done with this agency and we can ask a payback. Where is my cancel campaign? There it is. So I want to cancel my campaign here. And of course, this is going to be paid back only to the company that funded the contract with the ETH, not to the person who's calling it. And I'm pretty sure I actually protected from that. That only the, nope, I checked here. The payout can only be requested by the client. So that should not, I quickly thought this should be ownable, but no, everyone can use my contract. I don't want to restrict the usage of my contract, but only the client can request a payback, of course, and then we check the expiration. So here we go. I am on my customer. Okay, I have 27.5 ETH. Let's say, give me back my money. We again wait for this transaction to confirm, and I should get 0.8 ETH back. Voila. This doesn't need an Oracle interaction, so that should go quickly. Internal transactions, not showing up yet. Now it showed up. Okay, 0.8 has been paid, and it has been paid to my customer. Awesome. There's a lot more functionality that I can show, but actually I think this is enough for a demo video. So I'm gonna stop here. There's a lot of documentation which should help you go through these functions in the code. Thanks. Any questions, do hit me up. I hope to hear soon. Bye.